Hi everyone, are you able to hear me clearly? Okay, I'm going to turn off my Wi-Fi and then again test. All right, are you still able to hear me clearly? I have turned off my Wi-Fi. Great, 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 wonderful. All right, so today we are going to take our discussion forward on at the point where we left last time, and we were discussing something very interesting and something very new. All right. This one something I did it differently in the last session, and luckily it just struck me that this is a common problem related to parallel computing. Okay. So here, last time what we were trying to discuss was that when okay, so I'm going to all right. So a question there was that here this is where we left our discussion last time. Was it clear to everyone, or do I need to explain further? The problem was that we discussed that if there is a humongous data and we need to process that data, and can that processing be improved if processing is not so can the overall work be made faster? Can the overall work be made faster if the the main time is going on in reading from the disk? Okay, correct, Christine. So we can only go as fast as the red, right? Because if there are multiple horses in a cart can only go fast as much as the slowest one is. Okay. Read and write on the disk should be improved. That's the question from Jayaprakash. That's the point from Jayaprakash. That's correct. And Jayaprakash, I let me see if this file is being copied right away. How come this is not getting copied? I think this is the one. All right. So I'm sending today's link. All right. Jayaprakash, is this the? Did you mean the? You want? His question was that could you share the Dropbox link? So my question is that is this the notes that you're referring or something else? You're only referring to the notes, right? Okay. Okay. Yes. So let me see if that has been updated in the I mean the LMS. Actually, the mistake is on my part. All right, and how should I make a note of it? All right, so never mind. So I'll just make a note of it. Okay, to do at the top, I'll just keep making notes for today's session. Okay, move the notes to LMS. Okay, so this is what we're going to do. Correct. So we can go as fast as the red goes. Correct. Is everybody clear on this? Cool. Actually, Kamal is saying thanks for creating WhatsApp group. Actually, somebody from team only has created that group. I think he deserves thanks. And all right, I'll try my best to be active on WhatsApp group because for me typing on the phone is difficult, and I'm not, I'm already too much distracted to do things. So I'll try my best to stay active on the WhatsApp group. So I have added my team. I've added my team, as well as I'm going to add the CloudX Lab people into that, so that in case you guys are facing any kind of problem in CloudX Lab, your problem get resolved immediately. Okay. All right. So that's okay. So Pankaj is not on the. Okay. Let me just make a note of it, Pankaj. Okay. Add Pankaj to the group. Good. Never mind. So you just drop me an email. I can add you quickly. Give me the phone number. Okay. Just give me the phone number at say support at CloudX Lab. So I'll not support at CloudX Lab. Support at No Big Data. Good. All right, I'll add you. Great. So is everybody convinced about this point? If anybody has doubt, I can, explain again. Otherwise, we can move forward. So main point we were trying to conclude is that if a process has multiple phases, okay, and it is parallelized using many threads, the portion which consumes the maximum time will be the bottleneck. And this is something uh, quite if we go with the academia, it's quite well known theorem. Okay, I mean, kind of well known statement by one of the computing person called Dijkstra. DJI, somebody with that name. I always make a okay, I'll tell you the name. Never mind. So it's a well-known problem whereby if a compute, no matter what processor you add in this case, the processing will be as slow as the hard disk is. Okay. All right. Yes, it's not Dijkstra's algorithm. The person name was Dijkstra who said that the process cannot be made faster than the weakest one. Okay. All right. Again, the question, everybody who else is having this problem? I uploaded a file from Hue to HDFS, but it's not available. Okay. So basically, the question is that if you upload from Hue, okay, you are uploading to HDFS, while when you are logging into Web Console and saying ls, you are talking to the local, this is local file system, okay, because of that machine. Okay, keep this distinction in mind. Therefore, okay, therefore the only way to interact with HDFS is either using Hue or Hadoop FS and so on. Okay. Do I make sense, Pankaj? So there are many computers right now. Let's say I'm on no big data. Let me actually go through the usual route. Okay. So, all right. How come I'm not able to log in? Okay. Let me open my courses. All right, good. So, question from Pankaj is actually okay, interesting. Question is that he's talking about meta file. So, question from me to you is that when you said HDFS minus locations, do you get you get certain IP addresses, right? So was the node the console was console one of those machines on which the data was located as per HDFS minus locations minus blocks? Okay, all right. So Pankaj, can I'll love to take it offline if you do not mind. So yes, all right. So these machines, right? This one, and this one, this up to here. So it will be available on these machines. So this is A. Let me also take a look at. Never mind. So I'll have to take it offline. Okay, Pankaj? It's a good question, but yeah. A question from hers while executing this command. Okay, he's getting the error that use of the script is deprecated. Yes, so that's why use HDFS. Okay, use HDFS, FSCK. Yeah, you can use say HDFS. That's what we talked about in the class, that you can use this command. But that's not an error. That's just warning, because in future they are going to remove that feature. All right. Do I make sense, Pankaj? Should we go ahead? Yes, Harsh. Should we go ahead? Okay. So where were we, by the way? I'm kind of little lost. Okay. All right. All right. Cool. So this, I think we are at the right point. Thank you, Christine. And all right. Harsh, was I able to answer your question? So just use instead of Hadoop, yeah, use HDFS. Good. Let's move on. Okay, let me try to make it full screen. Yes, this is good. I would not be able to go full screen beyond this, otherwise I'll miss your questions. All right. So before going full-fledged into Hadoop, we would like to discuss the MapReduce, the first framework for computation. Okay, and then we'll try to understand the various other components as part of MapReduce. Good. All right. So in the first version of Hadoop, the total computation engine was a single unit. Okay, sometimes we call it monolith. Monolith means made of single stone, carved out of a single stone. So the MapReduce 1.0, that's what it was called earlier, it was a very simplified framework The framework was that the user would ask. So earlier in the previous class, we talked about name node, admin node, etc. Correct? So there was a name node, there was a data node, there were many data nodes. So if you have five computers in your machine, in your network, if you have five computers in your network, what you will do is you will install name node on one machine, and all other machines you will install the data node. Correct? That's what we studied earlier. Now, the storage part was good. It was done pretty well by using HDFS. Now the problem came to processing, right? And as we discovered recently in the previous question, that most of the big data problems revolve around the discrete speed, right? In the previous problem, if you notice here, it was the discrete speed which was the biggest problem. Now you cannot improve the discrete speed. The reasoning behind not being able to uh, increase the discrete speed is that if you are using the traditional magnetic hard drive HDD, you are essentially depending on a physical movement of an object, of a heavy object. And after a lot of research, people realized that it's better to store data in newer hard drives called SDD. Okay, the flash drive. Okay, the one that comes in the phones, the one that comes in iPad, or also in the MacBook Air. So that one is very comparatively faster, around 10 times faster. Now, even if disk is 10 times faster, but still it's not sufficient. It's not good enough. It's not good enough to process data fast. Okay, here in this case we are showing 20 milliseconds to read and 5 milliseconds to process. Generally the ratio goes to 20 seconds to read the pic and 5 milliseconds to process. So the ratio of processing to disk in lots of workloads, in lots of kind of works, is actually, even if you are using very fast hard drives, still the hard drive remains the bottleneck. Okay, now the only way to solve this bottleneck is have many computers parallelly in the network reading from the disks, use many drives in using many computers. And that's what the sole idea behind this kind of model is. So this is MapReduce 1.0, where we install somebody called Job Tracker on one of the machines. We install Job Tracker on one machine here. Okay. Okay. So you can see that we have installed just give me a second. So this one, what you see here is not quite used to using a pen. All right. So to make the whole processing faster, we are using this kind of model. Hadoop, the Hadoop MapReduce, the first one was modeled after Google's MapReduce, and it was pretty fast. And the way it was fast is that they installed job tracker on one machine and then installed task trackers on many machines. Okay, so you will submit your work to the job tracker, and this job tracker will hand over individual tasks to task trackers and let task trackers perform the duty. So what job tracker would do is, we will let's take the previous example, this one, where you have a million profile pics. So what it would do is, it would store, since these million pictures are already stored on many data nodes, right? Many, if you have already pushed all of this data to HDFS, so these pictures in the form of blocks will be stored on data nodes, right? So you will assign job tracker the task of processing this file. So you will give a program and you will give the folder name and then tell job tracker that, hey, can you run this program against all the files of this particular folder? Okay, let me take a step back, make it clear. So let's say you have a million profile pics. When you push those million profile pics into HDFS, they are going to be stored into the disk in the in the data nodes, right? The data is going to be in the data nodes. Name node will keep track of what file is where, what block is where. Now, so MapReduce made it possible to distribute the computing by the way of job tracker and task tracker. You give the work to job tracker assigns parts of the work to the task trackers, and once all the task trackers finish the work, it will hand over the results to you. Okay? Or you can say that it will save the result into the disk and hand over you the output, saying that, hey, we are done, here is your output. Correct? So that's the role of MapReduce 1.0. Okay, this was a very good design. It was able to solve your problem using hundreds of computers. So you assign the work to job tracker assigns work to task trackers. When all the task tracker finish the work, then you get the update saying, hey, we are done, it's here. Now, this all is good, but the challenge in this remains that you could only perform one kind of work called maps and reduce. Okay, so okay, before I jump further into MapReduce 2, let me see if I was able to explain. So you assign work to job tracker gives tasks to various task trackers. In case then task tracker fail, then that work is given to some other task tracker and get the work done, right? Now question remains that how is it solving our data problem? Okay, so when job tracker, so you ask job tracker, say let's take an example, that you ask job tracker to solve our previous problem. You will say that here is my script, which when executed against a file as argument, it will give you the optimized image or the output. So you wrote a program which get the work done, and you have already uploaded all the data into HDFS. Now you tell job tracker that, hey, here's my folder and here's my program. Can you run this program against each of this file in this folder so that I get the output? Now, job tracker will go to HDFS and say, can you tell me the locations of each of these files? Now, once it finds that location of the file, it selects the task tracker, those task trackers which are closer to the data as in the task trackers which are running on the same machine on which the data node containing that particular block is running. And that's how we run the process. Okay, so that's how MapReduce makes use of so many computers to solve your problem. Now, how do you structure your code? This code you write beautifully, which basically processes, say resizes here in this example, it resizes. So it resizes the million pics, correct? This kind of program, how do you write? Okay, do you write in the form of maps and reduces? So map function will be executed against every record in the input. In our case, every record will be individual profile pics, and the result will be combined together by another function of yours, which basically would process the aggregated result, aggregated by a key provided by your map function. Okay, so that was the model in the MapReduce. All right. So MapReduce, in the MapReduce phenomena, in this particular case, there will be no reduce phase, only map phase, because we are trying to run one program against all of the files. If we had to find out, if we had to find out which image is biggest, or group the data, group all the images which have the human face, in those cases you will need many images together, and thereby you will have the reduce phase. Okay, we will go into mapper reducer part later as we discuss more problems, as we will discuss more problems related to the data churning. Okay, all right, so let me take the questions related to this slide now. Okay, question from Hank is MapReduce MR for faster data processing? Answer is yes. Okay, Saba's question is the architecture will work. I mean, faster data processing, Hank, when I say here, it is to churn billions of record or terabytes of data really, really fast. Okay, so that kind of data cannot be processed using Oracle, MySQL, or any other database or file system. The kind of data MapReduce can process for you, because in MapReduce framework you will have thousands of computers running parallelly, or hundreds of computers running parallelly and solving your problem. Okay, so you have job tracker, task tracker, you assign the work to job tracker, and job tracker assigns the work to various task trackers which are closer to the data. And once the work is done, it saves the output in the map, in the HDFS, and that's how the framework used to work. Question from Saba is, this architecture will work if the data is distributed equally. If the data distribution is skewed, then that will be the bottleneck part. Yes, that's good point, Saba. That's why. That's why. So his question is, what if all the data is located on the data node 1? Wouldn't that be skewed? The whole work will go to task tracker 1. Okay? So that's a very good question. Let me try to answer this. This is an interesting question. If anybody else is having answer to this, I would welcome him to, yeah, him or her to explain further. All right, I would, right. So yes, this is a very good question. Question is here: does HDFS store data only on one data node? Answer is no. When you store data, HDFS by default, it moves the blocks such that the data is kind of distributed in the network. Second, the second part is that every block is going to have three copies. That means at least three machines will be involved. Correct? At least three machines will be involved. If this machine which is containing first block, a block, if it is busy, then the same block would be on another nodes, and thereby it'll be not possible. It'll be, sorry, I'm extremely sorry. So the first block would be on one node and the other two block must be on another node. So therefore at least three nodes will be there. So HDFS makes sure that this skewness does not happen. Question from Christine: when all tasks are done, which part merges the result to one set? That's called reduce. Okay, we will talk about that. Okay, question from Hank is like zip unzip? Yes. All right. So we'll talk about zip and zip part because let's say we are zipping all the files in using zip command. You will need all the files together to unzip, right? Therefore, when we talk about storing data in HDFS, we do not use the usual uh, zip and zip kind of format. Question from Kamal is: could task tracker and data node be on the same machine? Same for job tracker and yes, they used to be. Okay, so yeah, that's good. So yes, task tracker and data nodes are generally on the same machines, but job tracker, though the picture, though this photo shows that job tracker and admin node are on the same machine, but it does not have to be. Generally, we keep job tracker on one machine and name node on some other machine, but job tracker knows where is the name node. Job tracker, when we are handling the data to job tracker, we tell that hey, this one is the name node. So even if job tracker and name node are not on the same machine, they can discover them, right? When we are launching our MapReduce job, we do specify where is my name node, okay? Or it is picked up from the configuration file. Good question, Kamal. Brilliant set of questions. Christine's question is: HDFS in general is dependent upon equal distribution. Yes, that's correct. That's correct. Yes. Sandeep's question is: who does the load balancing? Can it be done manually? Very good question again. So, unlike in the RAID system where a lot of load balancing was done manually, it is automated. Generally, you do not need to do the load balancing. When you put a file in the HDFS, it tries its best to make sure that the data blocks are uniformly distributed. It should not be that one machine went overloaded while other machines are roaming free. There is something called data placement policy. Okay, data placement policy, or you can say, right, block placement policy. So, if you really want to have another way, and let's say you don't like Hadoop's way of uniformly distributing data, you have something else in mind. You can define your own data policy and customize HDFS. All right. You can customize the HDFS to specify your own data policy. That's a good question. A question from: is number of mappers equals to input split, which equals block size? Generally, yes. Okay. So, okay, we will talk about this a little while later. So, every file is broken down into blocks, correct? Now, these blocks are not logical, they are very illogical, as in I'll explain what does it mean. So file is cut ruthlessly at 128th byte in our case, 128th megabyte in our case, right? Every file, no matter the boundary was in middle of a file, middle of a line, middle of a word, it doesn't matter to HDFS. It ruthlessly cuts the file into blocks even if 128th megabyte is in middle of a character. When I say character, sometimes the character itself is multibyte, right? So, these blocks, before processing these blocks, certain boundaries need to be transferred between the machines, right? Because if something is cut on the boundary and you want to process that file, you might want to transfer the boundary things, correct? In those cases, you will convert them into input split. Okay, input splits contain records. Okay, input split is kind of made up of, you can say, contains records. Records could be, let's say you are processing plain text file. Each record could be a line, just like you have in database, every row is a record. Similarly, here in input split, it's the definition of input split. We can customize this definition of input split based on certain libraries. Let's say your file contained HDFS. Your file in HDFS was in XML. Then you would like to have different kind of input splits in case you. So it's a logical way of presenting data. Okay, let's say your data was in the form of a record based system. Thereby you would like to read data record by record, right? So yes, all right, if time permits we will go deep into this part as well. A question from Jayaprakash says that I think data will not be distributed equally. It will depend on storage space of data node. During distributing of data, some data nodes may not have to store data. So it will try its best to uniformly distribute data. Okay. It may be few megabytes more in first data node than the other, but it will try its best to distribute data. Okay. All right, very good set of questions. A question from okay, the question from Hank is that machine 123 is Hadoop 123, right? Kind of yes. If you see here, A, B, C. In our case, there are 7 machines. Okay, in our case, there are 7 machines, and one of them is the kind of name node and job tracker. Right, we will go into this definition again because we are not using MapReduce one right now. We are using the newer generation of MapReduce. All right, so if this is clear, I would love to move to the current latest MapReduce design. Should I move ahead? Good, good. A question from Christine: if you have 4 data nodes, I'll call it nodes. Okay, I might sound like nodes, but it's actually nodes. If you have 4 data nodes and one is offline for quite some time, when it comes back up, does all data get sifted around to quickly disperse? Yeah, kind of yes. Okay. In case the other 3 nodes are busy, they will start moving data slowly into the new node that has come up. Okay, in case certain file has been deleted, updated, that reconciliation will happen as soon as possible. Okay, a question from Dhirendra: where do we configure the number of data node that will be used for data storage? So this is something very interesting. So when we are configuring our system, so the way we have configured ours is using the this particular manual. Okay, so so what we do is we inform Ambari to install data node. Okay, and this data node is also this is also informed to the name node that hey, you have got a new data node, you can start distributing more data to this guy. Okay, So this is what we used. In case you plan to install, then you can do that. Okay, so basically we install Datanode on one of the machines and then we configure it in Hadoop. I'll show you the file quickly. I'm sorry, I went into wrong way. I should have gone to 9034. Oh, isn't that my login? 9034. Okay, so let me try this. Ouch, looks like somebody changed my password. e.cloudxlab.com 9034. Sandy. Oh, it is supposed to be something. Okay, let me copy the paste the password. I'm using SSH instead of using console. I can also use console using here, and that should be good. All right. So the configuration is here. When we basically are configuring Hadoop, we update the configuration in this folder. Okay. We configure this HDFS site that contains the information about our. All right. Okay. So you can see that this is the one of the data nodes. Okay. So we configure in this file saying these are the data nodes and that we can use them. All right. A question from Mrityunjay is, what happens if data is corrupt on one of the data nodes? How will it be identified and corrected? Very good question again. Okay. So Mrityunjay's question is, what happens if data is corrupt on one of the data nodes? How will this be identified and corrected? First question is tough. How will it be identified and corrected? So generally the way it happens is that Hadoop keeps the checksum of every block. What's a checksum? Checksum is the signature of a file or any data block. And that checksum cannot be so easily tampered with. Therefore, the moment even a single byte changes, the checksum will change, and therefore, the checksum will change, and therefore, that data block will be identified as corrupted. Okay, and whenever either while joining or retrieving or usual maintenance task when you run FSCK, these this identification happens. All right. And in case this is noted, that block is deleted and again is downloaded. Okay, if you remember, if you have ever seen the process of BitTorrent, in that case, let's say you're downloading a file. Sometimes what happens is, in case your network is flaky, lots of parts of that file keep on getting downloaded and dropped. Okay, similar mechanism is used here, and as part of any kind of system, you always have this way of ensuring something has been received successfully is either by CRC checksum or SHA-1 or MD5. CRC is fast, not very strong, while SHA-1 and MD5 are very strong. Okay. A question from Pankaj is, same machine can be used as name node as well as data node? In our case, yes. We are using it that way because what we realize, name node needs more RAM while data node does not need more RAM or CPU. So it is safe to utilize the drive of all the machines for data nodes. Okay. A question from Jayaprakash: is it possible to configure new name node and few data nodes in CloudX Lab for practice? The quick answer is no, but you can definitely try on the new machines at your own. Okay, you can have two virtual machine and try to install. All right. At CloudX Lab, we have everything pre-configured. So the objective was not for the admin training, mostly for the developer training. All right. Good. Great set of questions. Moving on. And where did we lose it? Yes, here. All right. So the problem, okay. So question from Dhirendra is, how can I view the contents of the name node? Okay. All right. So how can you view the contents of the name node? Okay. Question is, why do you need to view the contents of the name node? You can actually see Hadoop. You can use Hadoop fs command to interact with Hadoop name node. Okay. All right. Here we are not allowing people to log in into name node because name node always need to be, as we have already discussed, name node is quite a scarce resource, right? Like we were talking last time that e.cloudxlab got corrupted. So we could immediately switch people to F or add more nodes. But in case name node goes down, bringing it up, it takes a little longer time. Therefore, we are not allowing people to log in into name node on the machine on which the name node is. And even if you log in, you can only see the folders, but you can't. You are not. You'll not have permission to modify that. Okay. All right. A question from Hank is, data node and name node are assigned from Hadoop. These IDs basically we install a name node, okay, using the document I've shared. So we install Ambari and the ID, the which IDs are we talking about, Hank? Here, yeah. You mean H1, H2, H3, and so on? Yes, the block IDs, right? Data node block IDs are assigned by Hadoop. That's correct. So yes, Hank, the block IDs are assigned by that. All right, moving on. Okay. All right, sure, Azan. I'll take care of this part. That while talking, I'll be showing you in the console. All right. So do you mean that I should use this one or the web console? It's the same thing. It's basically SSH instead of web console. Why am I using it? So that I can switch between the browser and this terminal quickly. Okay, did I type a command? No, I think I did not type a command. All right. A question from Shashi. If same kind of requests are handled by data node, is there a concept of caching or will it process it again afresh? Good question, Shashi. Okay. All right. So good question, Shashi. So is there a concept of caching, or it will process again afresh? All right. So generally, name node or data node, meaning the HDFS, does not try to cache anything. Okay, because if it tries to cache things, then things will either consume memory, as well as this data which is consuming memory, it'll become inconsistent, because the moment we bring in the caching, the things start becoming consistent. All right, since we are talking about humongous data, it generally does not make much sense to cache. But having said that, as we will go forward, some of the workloads similar to MapReduce, they, I mean, the processing engines, they would try to cache part of the data. All right. Okay. All right. So Ajan's question is that I wanted to see what you had typed. Okay. So I did not actually type anything. Did I type anything? Let me try to see. Okay, okay. So this is something I was showing you, that in the vi.hdfs site, you will get the details. Okay, VI, instead of using VI, you can use cat or you can use nano if you are not comfortable with nano with VI. This is one thing I had shown, Ajan. Okay. All right. So I'll take care of this part in future. In case I'm typing command, I'll try to focus the console. All right. Okay. Question is, what big data engineer does on that? Okay. So generally, you will be writing the program which can divide the work and run on many computers. That's the simple answer to this question. So engineer, or the testing engineer, because testing software engineer is actually the developer. Okay. I mean, if you look at the software test engineers, they're actually developers. So all the developers, they basically convert the work into something that can be distributed, whether using MapReduce, whether using Spark, whether using Hive, or whether using Pig. So that's what an engineer does. Okay, Dhiren's question is, what's the difference between the Hadoop FS and Hadoop DFS? Basically, one was there in the old one, and one is the new changes. So it's just a backward compatibility. It's the same thing. All right. Question from Sandeep. Uh, can multiple nodes use the same cluster? How is it managed? Can multiple name nodes use the same cluster? In those cases, generally no, but in the federated structure, this is what happens. Okay, this is what happens. You remember our discussion earlier regarding the federated? Here, you can see that not this one, this one. You have different name nodes. They all are using same pool of data nodes. A question from Harsha is, if I delete a file, will, okay, if I delete a file, do all replications be deleted with it? Yes. It's not a backup, it's a mirror. Okay, it's not a backup, it's not to protect the data against a human error. It's to protect the data against physical hardware damage. Very great set of questions. I think I missed these parts. And if you do self-paced, these are the questions I think I'm going to miss. Okay, so which one is in new version and which one is in the old version? So you can check this out. So Hadoop FS, okay, so it would show you which one is deprecated. So if you see here, it says that instead use HDFS command. Use of this script has been deprecated. Either use HDFS or use Hadoop FS. So yeah, okay. So any admin related work you hand over to HDFS, and any interaction related work whereby the work is related to the seeing the details, either you use HDFS DFS or you use Hadoop FS. Okay, so basically it's a little mess up that they have done. So there is this one is equal to Hadoop FS equal to Hadoop DFS. Okay, but we will continue right now to use this one. Okay, yes, that's correct. So if you are doing the software test cell phone, basically you will be doing 99% of the work will be software development. Okay, this is my assumption. And unlike the manual one, because most of the testing actually happens automated in today's time, although there are quite a much manual work there. All right, good. Great set of questions. Let's move on. Now, okay, so MapReduce was great. It allowed us to process data using the map and reduce kind of logic. Okay, I mean, in MapReduce, you had to write two pieces of logic. One is called map, other is called reduce. Map contained, okay, map contained the logic which has to be executed against every record, and map was supposed to give key and value, while the reduce will get the data ordered by the key, and then all the values for each key will be passed through reduce. So if there are a million keys, then reduce function will be called million times. If there are 100 million key records, then map function will be called 100 million times. Okay, so now that model of map and reduce wasn't great. It was quite painful in many sense, right? So there were many kind of works that involved bigger kind of computation. Some wanted that we don't want a batch wise processing, we want our program to run continuously on the cluster, or some claim that they can do a better job than map and reduce functions. Okay, so while in case of MapReduce, the work of task tracker, data node, as well as actually converting, actually running the map functions and reduce function, all of this logic and the operating part. So there was one operating system which would divide the work, and then there was another part which was executing map and reduce function. Both were clubbed into a single framework. Therefore, it wasn't modular. Meaning, if you come up with your own way of getting the work done instead of map and reduce, you cannot divide the work. And therefore, Arun and one more person who created Hortonworks, they came up with this architecture that if we break down MapReduce 1.0 into two parts. One called resource manager, as in somebody who is tracking which computer is free, which computer is busy, and which one is executing what data, what code. So if somebody could track that and provide this information to all other people, similar to MapReduce framework. So MapReduce 1.0 contained two parts: one processing engine or workload engine, other resource manager. So resource manager was extracted out of MapReduce and we was called Yarn. Now Yarn absorbed the complication of getting work done in the cluster, while MapReduce became the client. The MapReduce framework is the client of Yarn. Okay, MapReduce framework become just another client of the Yarn. Okay, so this is the standard refactoring. We call it refactoring when we break down a bigger monolith component into two parts, such that it gives space for other logical units to come in. Okay, for example, earlier, like on a Windows computer, you could only run Internet Explorer for website things. But then they gave away so that other people could also come in. Netscape Navigator and others could come in, and Chrome and Firefox, they all could be installed and run on Windows. In the same way, the role of operating system, similar to operating system, the Yarn became kind of an operating system for the network because it tracks the resources. It keeps track of which machine is free, which machine is busy, and which machine is working on your task, and so on. All right, so this gave the way to many more applications similar to MapReduce became just one kind of application that you could execute on this operating system. Similar to MapReduce, you got Tej. Similar to MapReduce, you got say Spark, and that made wonders. This architecture breakdown changed the way people were looking at Hadoop. Hadoop would have become extinct if this change did not happen. This change made Hadoop more concrete because to manage a cluster, you need to have a resource manager, and you could not afford to install all kind of resource manager because every resource manager need to install the agents on all the machines in the cluster, and therefore you would not like to install hundreds of different kind of resource managers. Therefore there has to be singularity of resource managers while flexibility to execute all kinds of application or workloads. And therefore the MapReduce got the competition. MapReduce got the competition from people like Spark. And this also made it possible that HBase, Storm kind of systems could actually run on top of the same resource management. And this made it far more efficient because if there's a single resource manager is in how many machines are free, how many machines are busy, this can only be done by a single guy in a cluster. If let's imagine for time being that you have two kinds of resource manager, one is Yarn and other is somebody else. Now Yarn is executing its work while somebody else is also executing its work. Now Yarn does not know that somebody else is keeping my machines busy, while somebody else doesn't know that Yarn is keeping the machine busy. Therefore it was very much required that the resource manager is unified, single resource manager for every kind of workload, so that the load balancing amongst the cluster becomes meaningful. All right. Is there any issue with the audio? Okay, so let me take these questions. There are very brilliant questions that have come in. I would love to take those now. Okay, so first question is MR Spark Pig and Hive used to gather for big data computation? So, I mean, yes, maybe. Okay. So generally, the way people do is they. So I'll try to draw this. Okay, I'll try to draw everything on a single plane. Okay. So although we have already gone through the whole idea. Okay. So let's try to draw this. All right. This is. What's happening? What's wrong with this? I'm trying to use a new pen, so sorry about for the first time I'm trying to use. All right. So okay, so this is say HDFS. All right, I'll actually use the old way of doing things. I'm more comfortable still. Okay, so I'll try to explain. So you had this nice HDFS. Okay, so let's call it HDFS. And let's say there is a block above this, and we call that yarn. Okay, on top of it we have this is MR, and then you have Spark, and you have HBase, correct? So this one is keeping track of which machines are free, which machines are busy, where is it, and it's talking continuously to the HDFS. Okay, now on top of Hive you have these things called sorry, on top of MR you have Hive, and you have say Pig. Okay, on top of Spark you have other systems built, say for example MLlib and so on. So so you basically using these all tools you interact with Spark, which basically under the hood talks to Yarn, and similarly MR gets talks to Yarn to get the work done. Okay, I hope it's not hurting your eyes because I'm kind of colorblind, so I can't figure out what colors are great for eyes. Okay. So generally what happens is whenever we are working for a project, some parts you will be writing say MLlib. Okay. So let's say you're trying to build a big project. So some part would be in MLlib. Okay. Some part would be in Hive. Some part might be in MapReduce typical Java code. Some part would be say Spark streaming, and some part would be say graph. So generally in usually in a project you would end up using more than one component to get the work done. All right, let's say there is you are transferring data using Flume. Okay, and maybe transferring data using Scoop. So all those components will come into play. So you will use always, you will end up using always more than one component in the cluster. All right. So whenever you're working, all right, whenever you're working in a larger project, you generally have these different parts. Okay. So we will have a couple of examples whereby we'll be using more than one of these to get our work done. Okay. So Haricharan, are you still facing the audio issue? Okay, good. All right, looks like my colors were terrible, but okay, never mind. So I'll be a little careful next time. I'll choose the. So Hank's question is which part engineers work on? So generally the programming part engineers work on, but as a general understanding, engineers basically, take care of most of the parts. Integration is also the role of engineer in and verifying that things are, you know, so generally, the in case of this kind of ecosystem, let's say somebody is writing Hive queries, those are also engineers. People who work on MR, they also do is done by engineers. And generally, the only part that's generally left out is these Hive and Pig and Spark SQL kind of work that is done by analysts. Okay, Spark R will be another example, but rest, okay. So Spark R will be another example, and whereby the non-programmers can contribute. All right. So the for example, this ML lab here we talked about ML lab. This will be generally done by certain data scientists, while while in my opinion, um, doing everything was very much possible by an engineer. Okay. So, in my first project, when I started at in Mobi, the project was of recommendation. And as an engineer, at that point of time, I had studied numerical recipes and yeah, I mean that numerical mathematics, but I had never actually done the data scientist part. Okay, but soon enough, I started working as a on this problem of recommendation and prediction, and soon enough, I found that it wasn't difficult for me. And later, I figured out that I was pretty good with most of the analytics work because most of analytics work we have actually studied in our graduation. Okay, I was very clear about statistics and I was very clear about the machine learning part as well. It did not take much of a time to go through that. Okay, so most of the super specialist work, like data scientist, most of these algorithms are available in today's time. So every engineer can just pick up off the shelf algorithms as part of ML Lab and can get the predictions done. That is the beauty of our time. This is the beauty of our time that an engineer who is just a developer can actually get the entire stack up and running without the need of super specialized such as data scientist to be in the role. Okay. Pankaj's question is where does name node fit into the yarn as of now? So yeah. So you can see here, okay. So name node is untouched. Okay. Name node is kind of untouched. So if you have okay, so let me try to see if this is working. Okay, how do you take a picture in this? I'll try to explain. Okay, Little difficult to manage these windows. All right. Okay. So the question is, where does the name node fit into the picture? So answer is here. Okay. So the answer is here. This one contains name node. Okay. This one contains name node. Okay. As well as many data nodes. Okay. This one contains the various nodes. Okay. And they all talking to the yarn. Make sense to everyone? Good. Very great set of questions. Hank's question is, what programming languages are required? So generally in the real life, I'll be very honest with you, most of the work at say recommendation engine, I was able to get it done via Python. But later on, when we had to concretize it, we started with Java, and that also was fine. So mostly you can get most of the work done using Python. It's as simple as that. Okay. But if you want to do super specialized, you either use Java or Scala. Okay. If the efficiency and highly customization, then you go with Java or Scala. Okay. Java. Okay. Okay. So 90% of the work, I mean, almost all the work can be done in Python and or any other language. And it's just the super specialized work you might need Java here or here. Okay. So Sasi's question is, what's the difference between HDFS version 2? So HDFS 1 did not have the concept of standby and federation. Okay. Okay. So the answer is standby and federation. The HDFS 1 had this problem of secondary name node, right? That was removed by using standby, and if there are too many files, in those cases you could use federation. Okay. A question from Anuja. What's the language need in Spark? We will be going ahead with Scala. Almost everything can be done using Python. Okay. Python, except for GraphX. For GraphX, you will need Scala. Good. Very great set of questions. And we will be going through the Scala tutorial quickly. And I would say that if you are comfortable with any one language, going over to another should not be a big deal for you. All right. Great. I hope you. All right. So there were two reasons. The All right, so here the yarn part support for workloads other than MapReduce, correct? Because MapReduce was the only way of programming earlier on the MapReduce 1.0, and yarn helped us to bring the systems like Spark and others under the single umbrella. Scalability was another issue with the MapReduce 1.0, and Yarn was also compatible with the MapReduce 1.0. So people who had coded in MapReduce 1.0, their program actually ran successfully in the newer MapReduce. So it became easier to upgrade the Hadoop to Hadoop 2.0. Okay, so Yarn also improved cluster utilization. Okay, and agility. MapReduce was fairly batch oriented, so there was desperate need of a framework which is distributed and gets the work done. Now, who became who? In kind of MapReduce 1, there was only two things: job tracker and task tracker, and the unit of execution inside the task in the task tracker was task or slot. Okay, job tracker became three things: RM, AM, and timeline server. We'll talk about these things as we go forward. All right, and task tracker became node manager. Let's try to understand this diagram. This is a very interesting diagram, and I would like to, okay, I would like to take this further. All right, so yes, this is what the architecture of Yarn looks like. All right, let's try to understand it. This is a very important part, and we should try to understand it as much as we can. Okay, so let's see here. Okay, so all right, it's bad. Forget it. I'm just turning it off. All right, let's try to understand it. Okay, so in this architecture called yet another resource negotiator, the architecture became very different. Okay, but let's start with where we left at Hadoop 1.0. We had multiple nodes and there was one supervisor. People came to supervisor and supervisor gave the work to individual. Earlier, there were only task trackers on every machine. Here, there is something called node manager. Node manager, node manager. Okay, okay, so if you have 100 nodes in your cluster, there'll be a node manager on every node. Okay, and there is a single resource manager which is running on one of the nodes. The client comes to resource manager and says, hey, we want to get something done on individual nodes. Okay, or let's say there's a client that comes to resource manager and says, hey, I am the MapReduce, can you make me run on 15 nodes? Resource manager talks to all the negotiates with all the nodes and gives the place to various kinds of resources. Okay, it's a here, yeah, so client comes in, let's say there is a MapReduce client, and then there is a, this one is, let's say, MapReduce client. Okay, and this is Spark client. All right. So resource manager, MapReduce client comes to resource manager. Hey, I want to run certain MapReduce things. Resource manager says, wait a second, let me talk to node managers, and whosoever is free, I'll let you know. It talks to node managers, and then it says MR that, hey, you can establish your office in one of the nodes called B here. So this office is like the head office. Okay, it's like the head office. All right. And I think this can be explained better in terms of a typical industrialist way. So let's say, okay, let's try to, what do you say? This person is Bill Gates, okay, and this person is, say Walmart, okay, and this person is, say, President of United States, okay, and correct. And this is, say, mayor, okay, mayor of the state, or the city, or whatever you want to call it, okay, all right. So this guy, this is one mayor, this is another mayor. Good. Let's think of these individuals to be state. I'm not too good with the US politics, but yeah, I'll try to take a analogy. So these are the individual states, okay, these are the individual state. Now, so Bill Gates says that, hey, we want office nearer to these places. Okay. And then the president says, okay, let me talk to various mayors of various states if they have some space for you. Once that is done, node manager, one of the mayors, gives the place for this new company. So the first thing they do is they establish their head office. And that's what is known as App Master. This is per application. MapReduce will install its own App Master. And further control, further request for resources will happen from application master, or you can say head office, right? So this is the way everybody establishes. The way when Microsoft came into India, the first thing they did was they took a head office. They took a head office in Hyderabad, and from there they operated, right? At that point of time, the chief minister of Andhra Pradesh, they invited to Hyderabad, and that's how the same thing happens in Yarn as well. That one of the node managers allow, approve, or invite one of the process to establish their head office, and then that head office will demand more smaller offices. Okay, and that's executed inside another containers. All right. So container is like a typical office, whether it's a head office or branch office. Everything runs inside the container. Container makes sure that this office does not violate the law and order. In case of technology, in case of Yarn, this container ensures that the process does not access the resource which are not allowed. The process remains in the boundary of the memory. Whatever memory we have allocated for the container, it does not overflow. So the container is that boundary. Or you can say container is the legal office. So the office is bound by the law and order of the state. Similarly, uh, similarly, container enforces that law and order in case of Yarn. All right. So every kind of workload, whether it's MapReduce or it's any, so Bill Gates comes to the US president and says, "Hey, we need to open a head office." The president talks to the mayors, and mayors give, one of the mayors is selected, or one of the states is selected for the establishment of the head office, and then process goes on. Okay, then that head office will demand more offices further, and so on. Good. So question from Ajan is that each node is on separate physical server and the resource manager is on own server. So generally, yes, we must keep these node managers on different machines. Okay, although for certain demonstrations, people try to create uh, multiple node managers on a single machine, but that's strongly advised against. Similarly, we do install, generally people install node manager also on the resource manager, but that also is it is possible, very much possible, to install node manager on the same machine as resource manager, but it's too much to ask from a machine. It's overloading the machine. Therefore, we avoid keeping anything else on the resource manager. We generally have a single machine running the resource manager. Okay. Pankaj's question is, before going to the node manager, does it go to the name node to check where exactly the data block exists? Very brilliant questions. Very brilliant questions. The answer is it depends. The answer is it depends. In case this client, let's say this client is trying to establish its office near the sea. So while asking resource manager, it will say, hey, we want the office near the sea. So resource manager will only, or the president will only send the request to those states which are near the sea. And hence, in the same way, this client, let's say MapReduce, it says that, hey, I want my processing or my main processing to be the nodes which are closer to this data. In that case, resource manager first talks to the name node and figures out which are the node managers closer to the data and accordingly talks to only those node managers. This is called data localization. This is called a constraint. Constraint could be various kinds. One could be data locality. Other could be that, hey, I want minimum of this much processor. Or constraint could be that, hey, I want this much of RAM. If that much of RAM is not available for this particular client, then the processing does not happen. Okay, so client, when submits the application to the resource manager, it writes down that, hey, I need one office which should be of this size, and so and so. Resource manager tries to find the best match after negotiating the various node managers and then establishes the office. Okay, so I'm mixing the two things continuously. So client here is I'm continuously switching back and forth between the real world and the client. So I'm hoping that it'll be clear to all of you. So MapReduce or Yarn, when they are submitting their application to Resource Manager for the creation application master, the process starts. Okay, at that point of time, the client also submits the data localization constraints, or at later point of time, the first role which was initiated by client is taken over by this application master. This application master further talks to the resource manager, says that, can you please run this program? Can you give us some node on which we will run our logic inside that near to this data? Application master and client both submit their application to the resource manager. Okay, all right. One is the client which is submitting the application for the establishment of the application master. And application master is, if there are more work to do, then application master will further submit the request to the resource manager. Okay, here is a standard flow. Client submits the application to the resource manager. This application contains that I want near this data this much CPU, this much RAM. That's the application definition. Resource manager launches application manager in one of the containers. Okay, after negotiating with all the node managers, resource manager zero down on one of the node managers and starts application master. Once application master is created, it registered with resource manager so that client can talk to the application manager. It's like once the office is established, you are setting up the phone lines and setting up the remote monitoring systems. Okay, so that the client can monitor that whether the company is running fine or not. Similarly, the client can hear the client is monitoring the application master. Okay, now the role is switched to application master. Application master is now representing the client inside the system. Now application master goes to the resource manager asking for more work to be done, meaning more containers. This resource manager allocates the containers, and resource manager launches the app in these containers. And node manager talks back to the resource manager about the resource usage, and client talks to the application master for the status of whole process. Okay, on completion, AM deregisters with RM and shuts down. All right. Wow. Now let me take up the questions. Or do you want me to take a break before taking up the question? Wow. These are okay. Okay. So let's take a break and then come back from the question. What? Okay. So let's take a break for 10 minutes. All right. Back by 9:48, 50 p.m. IST. Okay. And all right. Thank you, Christine. Or you can say to 11:20 CST. All right, so we can start now. So Rana, this access to all of these videos will be there forever. Okay. And you can use the tools for downloading the video from YouTube downloader. So although we will keep all of these video available for lifelong, but if you want, you can also download it from YouTube, okay, using the third-party tools. All right, there are very brilliant questions I would like to address and try to see if I'm able to. All right, I think I have answered. Each node is on separate manager. I think this one I have answered. Okay. So generally we try to keep node manager and resource manager away from all kind of workload so that they don't go down. Okay. A question from Pankaj. Before going to node manager, does it go to name node to check? Yes, that is good. All right. Next is from Christine. Although she got the question answered, but it's worth explaining because others would be having the similar doubts. Okay, is app master always on B for all Bill Gates request? Yes. For basically, I will explain this in detail in the next slide. All right, let me cover that slide. Okay, before we jump ahead. All right. We'll come back to the previous slide in a minute. So a resource request, meaning when you want to establish your office, this is the form that you need to fill. Meaning when a client is submitting the request to the resource manager, the form it needs to fill is how many containers would it require? Do you want it all of this upfront or as you go? Meaning, do you want it only for application master or for rest of it? Okay. So resource request is e- this much memory do I want, this much CPU I want, and the locality constraint like near this data. All right, that's my request. That's the request the client submits to the yarn. And who is the client? The client is MapReduce client, Spark client. Those libraries are the client. Those libraries are the client. As we'll see further, that every every application developer will create the logic that will run in the client as well as the logic that will run inside application master. Okay, is the duty of the framework creators like the people from Databricks who have created Spark, or people from Hadoop who have created MapReduce. All right. Now there are three kinds of there are many kinds of applications. One, okay, so the application lifespan does vary a lot, and vaguely they're categorized into three. One is one application per user, one application per user per workflow, okay, per workflow, or you can say user session. All right, I'll show you this as we go forward. Okay, so the one is per job, per user session, or long running. These are the three kinds of processes. Let me describe each one and then go back to the points we were talking earlier. The simplest case is that I submitted my application, the work got done, I go home back. That's called per job. Okay, per job. All right, per job, the application master, whichever was created, it will get deleted, and if somebody else submits a job, it will create the application master again, and so on. Second is per user session, meaning application master will be created for me. Now I can continuously keep on talking to application master. Just the way, just the way right now I'm logged in here. Okay, the cell is being so the just the way this shell is accepting commands from me continuously unless I end the session by pressing Control D. It will keep on running, it will keep on accepting the commands from me. Right now it's waiting for command from me. These are called per user session. My session is opened. Unless I close this session, I can keep on getting my work done. Okay, this is the case with Spark. The third lifespan is the long running process. A server, for example, when an HBase server runs, it keeps running forever. It does not depend on the user session or per job. It keeps running forever. These are infinitely running, infinite lifespan kind of process. Any process which is consuming continuous data, or the process which is continuously absorbing data from the network in the form of stream processing, all of those are generally long running because they do not end. If the data is not there, they wait for data to come in. If there is no request, they wait for the request to come in. All right, those are called long running process. Good. Now going back, there are quite a brilliant questions. So this first question is, app master always run on B for all requests, is a very difficult question to answer. So answer is that, so this request, which was so for example, first client came up with MapReduce. First MapReduce will application master, meaning the head office for this MapReduce, will be created on one. Maybe if the second MapReduce has started again, application master for the second MapReduce will be created somewhere else, because MapReduce job are per user submission, not per session. Okay, every time a user submits a job, the application master is created and work gets done. Okay, now if it is second one, like in case of Spark, when you have one per session request, per user session request, as in so let's say first user came in, it wanted some work to be done. If he has some more work to be done, it will be the same application master. But if some other user wants to get work done, there could be another application master. Now, if it's a long running process, the chances are in all kind of circumstances, whether the same user or different user, same job or a different job, there will be a singular application master. For example, if it's a HBase, there will always be a single application master. All right. So I was not doing anything. I was just on this particular screen. Okay. Actually, I by mistake clicked on the pause button of the video. All right. Okay, so actually, yes. So I've disconnected my pen. I think that pen is a big difficult. Okay, so Anuja is saying I did not understand what you explained after the break so far. Okay, so I was explaining that the lifespan of an application is three kinds. One, per job. When you submit a job, you get the response. That's one. Then there are other kinds of job, like for example, when you open MySQL command prompt or you open any command prompt, the session remains as long as you are active. Similarly, let's say you are starting a transaction from SQL. That transaction is generally per user, okay, per session. So, so that's kind of second model, okay, second kind of lifespan. Third is something that runs forever. Good. All right. Um, okay. I was trying to explain this particular question. Anuja, did it make sense to you? Okay. Good. All right. Going back to the question, there are quite interesting questions, and I'm sure these questions will help you a lot because these are the questions that interviewer will might ask you if you want to get hired. Okay, because these are real, genuine questions. Okay, so where was I? Here. Good. So the next question is if Steve Jobs makes a similar request, does it go to the same application master or might go on it will go on to different application master. For every different job, there will be one application master. Okay. All right. Deborah's question is where do name node, data node, job tracker fit into this? Okay, I hope you got the answer. So name node and data node are separate. They're running independently. Okay, they're doing their job, maintaining the data. Task tracker has been replaced with this model. Okay, task tracker has kind of become the node manager. And the in Hadoop 1.0 there was concept of job tracker and task tracker. Now it's resource manager and node manager. All right. All right, good, great question, Christine. All right. The other question was, I think it's a rewording of the same question. Is application master just a logical concept or used per client request? I think you got the answer. There are three kind of okay. So you can always think of container to be like a Java virtual machine. What is a Java virtual machine? Java virtual machine is kind of a process which is running your logic inside it. Just like a process, container is that process running inside on the operating system. Okay, Hank's question is who is tracking the resource availability? Resource manager is basically tracking the node managers and what kind of job is getting executed where is being tracked globally by resource manager. Okay, but and with the help of all the node managers. Okay, node managers are responsible for getting the work done on that node, while resource managers generally tracks what process, what containers are running where. Okay, Kamal's question is, if two MR jobs come one after the another, will it initiate two MR app master on two different node managers? Yes, it will. Okay, a question from Hank. Like cell tower to be accessed, the best strength, signal strength. That's correct. Another question is, what is the difference between node manager and app master? Node manager is responsible for all the nodes, while app master is created per application. Okay, application, but some application master would be for MapReduce, some would be for HBase, some would be for say another MapReduce job, or some would be for Spark. Therefore, this system of execution, in this system of execution, the node manager is the owner, while app master is kind of a guest. App master will be destroyed after the work is done. Node manager is the mayor of the state, while application master is a external company who has established an office there. Okay, very good question, Bharanidharan. Okay, technically, application master and containers are library or executable or services. Okay, technically, application manager and container are libraries or executable or services. Answer is services. Okay, very good question, Bharanidharan. Okay, so yes, so these are services. They run on particular port. Okay. Hank's question is, how about slides? So slides are all available in No Big Data. Are you able to see these? There is a presentation here. There's a presentation here. And all of this data is, all of these slides and everything is located in the LMS. All right. You must be able to see it. Okay. All right. There are three, four questions more. A question from Mrityunjay. Question is, so is there a limit on application master? So there can be hundreds of jobs. So does it mean that application master always matches number of jobs? Is there there can be hundreds of jobs. So for every kind of job, okay, every kinds of job there would be application master. In case of MapReduce, there would be one application master per job. Okay, so it depends on available nodes. So it depends on the configuration when we set up. When we set up Hadoop, we define how many maximum containers every node can execute and how much maximum memory can every node go up to. Okay, so if application masters are going beyond that memory, those will be killed. Okay, similarly, any other task that application master executes, they will be killed if they go beyond the maximum memory allocated for container. Similarly, if containers, number of containers have all exhausted, Let's say we have said that 4 containers per machine, and all of them are exhausted, as in something is running on one or the another, whether application master or some other process is running inside the container. If total containers are consumed, the process shall have to wait. You will get either the error after a point of time, or it will say that waiting for node managers to give me the containers. Okay, so most likely you will get an error in case you have exhausted all the containers. A question from Saba. Once Very good question, Mrityunjay. Once the application is done processing, will it kill itself and update the resource manager? So as soon as basically when application is done processing, it will exit. Just the way, just the way when you run a program, it's doing certain thing, and as soon as the processing is done, the control returns to you. In the same way, it as soon as it finishes, it'll return to the resource manager about its current status. Okay. A question from Anuja. What's the difference between node manager and application master? I hope I have answered this, Anuja. Node manager takes care of the node, and application manager is okay. A question from Kamal. All right. Can it run on the same node manager and create two application master on the same node manager? Yes, if that node manager is has not exhausted all the containers. Okay, I hope I have answered your question, Kamal. A question from Christine. Is there one Yarn node manager per Hadoop data node? How does the container interacts with the data manager? Let me read it again. Is there one Yarn manager per Hadoop data node? Okay. So generally, yes, not data node. We generally install node manager on all the nodes. Okay. Sometimes because the thumb rule is that we install the data nodes and node managers on all the nodes in the cluster. Why? Because every node has certain disks to spare, and every node has certain processing power to spare. Okay, and data node does not require processing power, and node manager does not require the disk. Correct. Therefore, generally data node and node manager go hand in hand. All right, and hence we generally install. Sometimes maybe you are running a node manager on a machine which does not have the storage, or sometimes you do not want a certain machines to do computation. In those cases, you would not put both the things together. All right, did I make sense, Christine? A question from Jayaprakash. Could you just brush up containers responsibilities? Okay, so every minimal amount of unit of execution is container. Okay, okay, or look at it this way: whether you are a finance company, or you are a pharma company, or you are a consulting company, software company, anything, everything runs needs an office. Correct. In the same way, whether it's a MR job or Spark job, Their application master or individual work, the mapper or reducer, whatever they want to run, it will always run inside this office or the boundary called container. No matter what execution you do, it will happen inside container. Okay? So container's responsibility is to get actual work done without letting the law and order violated. Meaning, what is law and order here in case of yarn? Without letting application cross a boundary, such as number of CPU consumption should not go, it should not consume RAM beyond a certain size, and so on. All right. Yes. So whether it's individual mapper, reducer, Spark job, HBase job, this job, that job, everything runs inside container. Do I make sense, Jayaprakash? All right. Haricharan, was I able to answer your question? Good, good. So there was a repeated question. A question from Swan is, if there are 10 jobs, if there are 10 jobs in MapReduce, how many application master be created? There will be 10 application master. Okay, but if there are 10 jobs for HBase, there will be one application master. All right, as we discussed the three kind of applications: one per job, second per user session, third the forever. Okay, the forever one, there will be only one application master. Question from Mrityunjay is, can we schedule and prioritize job to execute in sequence? So that's kind of the role of resource manager. We can always ask resource manager for more resources in the request. A question from Harsh, where do we maintain the information about number of application manager, number of container? Is it the yarn config file? So no. Number of application manager. Let me try to understand this. Okay. All right. These are good set of questions, and these should be, everybody should pay attention to it, even if it's not your question. Where do we maintain the information about number of app master? So this one you don't have to, because the yarn it's dynamic, because every time a request comes in, it will create an application master if it is job per job, and resource manager will keep on track of that. Now, the number of containers, these number of containers, we define how many applications, how many containers can be there per node. Okay, let me digress a little bit. Okay, let's take a look at Ambari, then it'll make more sense to you. Okay, all right, you can take a look at here. There are one data node is dead. Okay, so there is name node and there is data nodes. You can take a look at their IP addresses later on. Here in the yarn, there's something called resource manager. Okay, and this is running on this machine. And if you go into the resource managers, say yarn, and if you go into the config of yarn, you will see a couple of very interesting things. Okay, here is something that I was talking about. Here we are defining how much memory each node, uh, how much memory for the for all yarn container on the node. Total memory, how many memory you want to give in total, as well as you can see containers, minimum container size, how many CPU you want to give to the container. Okay, all right. So if these containers exhaust this memory, then they can't be run beyond that. All right. So here we are controlling how much memory, how much CPU we are allocating for the all the containers on the particular node. We are saying 80% of the machine can be dedicated to the containers running on a node. Rest 20% is given to the other operating system job on every node. Okay. Similarly, here we are saying that total memory allocated on a node for all the containers is 4 GB. So if our average container size is 5 MB or say 4 MB, there could be 1,000 containers on a single machine. A question from Jayaprakash: will more than one app master run on one container? No, one container per job, per task. Okay, container, the work given to the container, a container cannot have more than one work inside it. All right, I hope that clears your question, Kamal. No, Harsh. Kamal's question is, if container failed to give response or result, how will it be notified to NM, and resource manager? If container failed, the first information would go to the resource manager. Resource manager will try to negotiate with another node manager and get it done somewhere else. Okay, in case if one of the containers has died, it'll again resource manager will talk to other node manager or the same node manager to try to create the container. So container will be attempted again on the same node and then on other nodes. Yes, Jayaprakash, container provides execution environment for application master. All right. Dhiren's question is, so Yarn is mainly concerned for configuration part of the resource manager and node manager. Do we use any command like Hadoop FS to interact with Yarn? All right. So there are two parts of question. So Yarn is a framework. Yarn is okay. So when we say yarn means this plus this. All of this box is called yarn. Okay, Yarn is like a country where you have president and the mayors of the state. Okay, next question is, do we use any command like Hadoop FS to interact with Yarn? Answer is no. Generally, when you want to interact with Yarn, you basically write a program and then get it executed on Yarn. Okay. Question from Hank. CPU scheduling is based on priority or preemptive? Here it's based on the preemptive. Okay. Whosoever comes first and based on the availability of the resources. Question from Kamal is, can a container have both a task to perform as well as application master? The answer is no. There will be two separate containers, one for application master and other for a task to perform. Okay, so container cannot have a single container cannot have, but concept wise, whether it's application master or individual task to perform, everything runs inside a container. Okay, a question from Shashi. If a process takes more RAM than configured on the container, it gets killed. But what happens to the processing done before it hits the threshold? Will it be lost? So, no. So, if it's writing to HDFS, if your process is writing to HDFS, it will be saved. Otherwise, the outcome will be lost. Anuja's question is, client cannot talk to container. Client can talk to container via RM and via node manager. Okay, because client doesn't know about the container, but once your program is running inside the container, let's say application master is running inside container, it will hook back and kind of throw a rope from inside to outside so that you can talk to it. All right, so client can talk to the container via establishing the registration as we have talked earlier. Here, this one, if you see here, once it registers, this application master, it registers, then they start talking. Okay, they start talking. You can see that. All right. Do I make sense to you, Anuja? Good question. Containers are nothing but programs. Yes, you can always think like processes, like when you run Chrome, it's basically a constrained environment in which a website can run. Similarly, the virtual machine is kind of a container or Java virtual machine, and so on. All right, good. Great set of questions. I hope you got the idea about the about what goes on inside Yarn. All right. Now the next question next is again the same part what we have discussed. Application client goes to the resource manager, submits an application. It gets this machine called this machine in which it runs its application process. Now this application process further goes to the resource manager and gets another container and so on. So this chaining is what happens. All right, so the client goes to the resource manager gives an office for the head office, then head office requests for more offices and get more offices created for the for getting work done. All right, so that's what goes on inside Yarn. It looks a little complicated, but it's very important to understand, because as we go forward, you will see the whole magic unfurling. All right. Now, sometimes as a developer, you would think that, hey, we do not like MapReduce, neither we like, say, Spark. Let's create a new one, our own application to fit your kind of need. Okay, so here is my advice if you want to create your own MapReduce competitor. All right, first try to use and understand existing frameworks such as MR and Spark. Because creating a yarn application to do all of this magic is little more involving. Second, try to use either these frameworks like Apache Slider or Apache Twill that make it easy to create a yarn job. Otherwise, otherwise you can use this particular project called distributed cell application from the distributed cell application from the example provided by yarn package itself. All right, so we have talked about all of this already and would like to move on. All right, I think we all are on the same page. All right, in this class I'm not going to go detailed into Java MapReduce. Instead, we will focus only on the basics of MapReduce, and then we will basically try to understand more towards basics of how to get something done over MapReduce. All right, all right. I think this is pretty much. All right. So okay. So here is another problem to all of you. Quickly, it's not a precision kind of thing. It's just a vague answers I'm looking for. Even if you are 100% off, as in instead of saying 1 hour, it's you say 2 hours, I'm completely okay. Okay. So question is, how fast can 1 gigahertz processor sort 1 terabyte data? And this data is basically 10 billion names containing 100 characters each, meaning 10 billion names, each of which is of 100 characters. And this computer is simply 1 gigahertz computer with 2 GB RAM. All right. So Christine says, all right, I'll not say that because I think that's visible to everyone. All right. So what does your gut feel say? That's what I want to see. 1 terabyte. Okay, 1 terabyte. 1 terabyte, when you buy a desktop, when you buy Xbox One, you get 1 terabyte hard disk, right? So let's say you have data of 1 terabyte size such that It contains 10 billion random strings, each of which is 100 characters. You want to sort these 10 billion strings. Sort means order by in certain order. Let's say in lexical order. Lexical order means the way things are kept in the dictionary. Okay, the way words are kept in the dictionary. Yes, Ajan, the 1 terabyte is quite a usual space. I have just built a storage of 8 terabyte for my home so that we can store the work. All right. So 1 terabyte is quite a usual one. All right. All right. So question here is that how fast can it process? So it can actually take somewhere between 6 to 10 hours. Okay. Based on if you are using SSD or okay. So it could, yeah, it could even go up to say 20 hours based on what kind of hard drive are you using. All right. So all of your answer is correct. The only thing I'm trying to see is that it takes time. All right. So I mean, where did you encounter sorting in your career? Anybody? Have you encountered sorting in your career so far? So there is no way of calculation. It is just a kind of the experience. All right. There's no straight way of computing. So generally, the way you can compute easily is, say, most of the time is going to read the data from the disk. And if you know the speed at which you can read the data from the disk, you can generally compute. Or if you are writing the data, then again, it's going to take a lot of time. All right. So the problem is that we need faster sorting method. We might need bigger data sorting, meaning today it is 1 terabyte, tomorrow we might need to sort 2 terabytes, and we might have to do it more often. All right. Now, sorting is an important problem. Okay, I'll talk about why it's important. All right. Sorting is quite important problem, and every technology giant does the chest thumping on the sorting problem. In 2011, Google published a report saying that they have sorted 10 petabyte data in 6.5 hours using 8,000 computers. How much is a petabyte? 1024. Okay, this is 10,000 times 1 terabyte. And they were able to do it using 8,000 computers, less than what we will do using one computer and 1 terabyte data. They were able to do it far more efficient, and this was done using Google MapReduce, or you could say Hadoop MapReduce that time. All right. So basically, this was the number that justified the use of Hadoop MapReduce for humongous data. None of the existing mechanisms at that point of time, whatever existing mechanism were there at that point of time, nobody could ever think of 10 petabyte data. And Google did the sorting of that data. All right. Now, why is the sorting important? Why do we talk about sorting? Almost every computation is a sorting in one way or another. There are certain computations which are far beyond and far more complex than sorting. All right. So the sorting you must have encountered earlier would be in the form of creating index. Every SQL query is impacted by the rate at which the data can be sorted by the database. Okay, so every SQL query is impacted by the sorting algorithm. For example, when you say where clause, when you say select star from my table where such column equals to that column, if there is no index on that column, the results will be very slow. Therefore, Therefore, selecting data from the table is impacted by sorting. Indexing is nothing but sorting the data. Indexing is like on the back side of the book, you see the index, right? In which all the keywords are available in the ordered way and with the page number mark. That's called indexing. And every table is impacted by indexing. All right, everywhere clause is impacted by the fact whether there is an index on the column which we are searching against. Right, when we say select star from this table where my name equals to Sandeep Giri. So my name, this column called my name, if it's not indexed, then the result is going to be very slow. Then group by, it involves sorting. Join, immensely enhanced by sorting, right? Group by is of course sorting because first it sorts by the column on which you're grouping, and then once it is sorted, grouping a sorted data is very straightforward. You could go top down, and then as long as the value is the same, you keep on grouping under a bucket and then move on. Third is, okay, joins are immensely enhanced by sorting. Okay, so if there are two tables which we are joining, right? If we go if we go by this way, that we pick a record from first table, try looking for that record in second table, and so on, right? That will be very slow. If on the same at the same time, if you sort both the data, index the data, and then it becomes very easy. It takes a linear time to join two data sets if they are sorted. Then order by is of course obviously the use case of sorting. Then so you can see that every SQL query kind of directly or indirectly gets impacted by sorting. So there are two facts which we have talked about so far. One, sorting, and other, read speed of the disk. These are the two. If we could improve these two, then we'll be able to do a breakthrough in the computing industry. And that's what Hadoop MapReduce did. Because what they did was, what Hadoop MapReduce did was, it made it possible to execute the job near the data and utilize multiple CPUs and multiple disk reads to solve this problem. And Hadoop MapReduce is a classic sorting algorithm. Okay, it's a classic sorting algorithm. We will talk about it in details. All right. So those algorithms which do not involve sorting, for example, classification or clustering, we'll talk about those later. There are quite a few algorithms, complex algorithms that are not sorting directly, but they involve sorting or they can be improved by sorting the data. All right. So let's talk about what does it mean by MapReduce. All right. So today we're going to talk about MapReduce, and then we'll go into the details about how does the MapReduce work, and then we will go ahead with the rest like Hive and Pig quickly to understand. So we are not going to go very details into MapReduce. Okay, we're going to just understand how does it work. All right. Are you guys with me so far? All right, let's just go through it. So, what is MapReduce? MapReduce is programming paradigm to help you solve big data problem, specifically sorting intensive job or disk read intensive jobs. All right, so you will have you generally code two functions. One is called mapper, which converts the input into key and value pairs, and you can optionally code reducer. You can write reducer code. If you don't have any reducer code, that was the case where we were trying to resize the image. There was no need of reducer because we were not trying to aggregate everything. We only wanted to convert one photo into another. In that cases, a mapper was sufficient. But in case you want to aggregate all the values for a key, which key? The key that was given out by the mapper. So mapper strategically gives out key and value. And who decides what key or the value to spit out? Your code, your logic. You will write a logic in the mapper that here is my record, input record, let me process it and give this key that key, so that in the reducer all the values for this key are going to be together. All right. All right. So it is also supported by many systems as of today, whether Spark, MongoDB, CouchDB, Cassandra, and that's the reason why we are discussing. If it was not supported by others, there was no point of going into the details about MapReduce. MapReduce is the standard phenomena in the procedural language for distributing the logic. Okay, so we will talk about more into the details. In case of Hadoop, you can write this piece of code, mapper or reducer, either in Java or in Shell or in Python or in any library. Okay, so this is the general flow. This is the general flow. Okay, so again, let's just do a quick, walk through. So again, this block, what you see is, it is the piece of logic that you write. This block is the piece of logic that you write. All right. So, so the data is read from the disk into input split. Okay. Each data block. All right. Let me try to again try once more if I can draw something on top of it. Okay. So here, let's say, okay, let's say there is this nice HDFS block. Okay, this is your HDFS block. There's another HDFS block. There's another HDFS block. Good. From there, the data is passed into input splits. All right. Might be a certain slight movement happens here. So input split is basically a logical unit. Why are we talking about input split? Because the same thing is going to be used by Spark as well. Okay. So this is the data. This is the raw data in the HDFS. This is this boundary that you see here is what happens here. Okay, let me close it. Yeah, so the boundary that you see, this one is HDFS. All right, this is HDFS here. Okay, so HDFS is containing data nodes containing these block 0, block 1, block 2. Okay, so when a MapReduce job is executed, this is what goes on inside kind of application master. That first the HDFS, this data is going to be located where it is, and then on every node, this is what is going on. On every node, this piece of logic gets executed. This logic executes on every node. All right, wherever data is there. Okay, Hank's question is what facts are separated by key and value. Don't worry, I'll explain what does it mean. All right, and yeah. So let me. I think a better job would be to try to explain without the reducer pass first. Okay, so here I'll take an example. I think that's a better thing to do. Okay, let me duplicate this slide and make it look a little nice here. All right, up to here. All right, this is how it's going to look. All right. So I hope this is clear. So from SDFS, raw blocks are translated into set of record. This is one set of record. This is another set of record. This is another set of record. A record could be a file. A record could be image. This is decided by input format that you configure as part of your job. Okay. Now going back into the details. All right, so you can, yes, good. So you can look at this one. So here there was image one. This is your again the same example where you have to process a million images. Okay, so I think I'll change the color to say blue. So image one, image two, image three. Okay, or maybe image four here. Let's say image 5. Okay, and let's say image 3, not 3, let's say 6. All right, so let's say there are 6 images that you want to kind of resize. All right, you want to resize these images. Let's say these are profile pictures of the people. You put these images into a folder. Okay, and write this piece of code called resize. Inside mapper, your code will be let's say define your function and let's say you are using image magic library to resize the image. Okay, so using image magic, all right, or let's say I'm just writing it for resize. Okay, so this resize function is something you write as a piece of code. So you wrote this piece of code called resize, which takes an image in the input and converts that into a different size. All right, so when you are calling the MapReduce job, you tell that, hey, here is my folder. You provide the following things. Number one, the folder containing data, containing images. Second, you provide the map function, which contains the logic for resizing, and output folder. Okay, and what else do you provide? The input format. Okay, that converts the raw data from the file into something meaningful. And then so when Hadoop will be running your job, it'll resize every image, and there is no need of sorting. Actually, there is no need of sorting. How can I just cover this part from here? So how can I just cover this part? Because there will be no need of sorting at all. Okay, there will be no need of sorting at all. The data, instead of going to the sorting, it will actually go to from here to HDFS. Okay, it'll again go to HDFS. The output image will directly go from map to HDFS. All right, I hope this is very clear. So it's a job where there is only map and there is no reduce. All right. All right, so I'm hoping that I had created earlier a diagram depicting the same thing in the, where is that? Mhm. Introduction. So are you with me? And or should I? Is everybody sleeping? Knock knock. Yes, I'll give you that real value of the key value pairs. Let me try to explain with the proper diagram. I had created a diagram earlier. I'm trying to just figure out where is the diagram. All right, so okay. All right, can I just copy it again? Yes. So from here to here. All right. So yes. All right. So instead of this, we would have like this. Okay. The data will come from HDFS. Okay, and data will go to HDFS. So this is clear, right? So now let's try to go back to the problem I was discussing. Now let's take another example. Imagine, imagine you have a text file containing temperature and cities, okay, and location, all right, separated by and time, all right. So let's say the temperature was 20, city was say New York City, and yeah, location we can remove right now, location, and then time is in the form of 2014 0101, then 23, and say suggest a name, and so on. Okay, so let's say BLR, and then 200101, then 25 Seattle, and say 20160101. All right, and there will be many entries like this. Okay, some for this, some for another date, and so on. All right, is everybody with me? Okay, let's put some more. 21 Chicago and 20130105, and so on. Okay, so this file contains the temperatures of various cities. Now let us say you would like to find out maximum temperature per city. Let's say you would like to find out maximum temperature per city. Okay, so had it been in database, you will basically group it by the city, right? And then compute max. Okay, question is max temperature per city. Okay, answer is the mapper code, whatever you write here, it would give out the name of the city as the key, and this is the key. Okay, this is key and value. Okay, so your mapper code, whatever mapper code will, what it would do is it will basically line is split by comma. Okay, and then it will take this is temperature, comma city, comma time, and so on, and then it'll just give out the city, comma temperature. All right, what is it that we are trying to achieve? We are trying to find out the max temperature per city. All right, so in such scenarios you want to group the data by the city. So whatever key you want to group your data by, you create that key as the mapper's output and leave it to Hadoop. Hadoop will automatically group the data based on that key. It's not your job to group it. You hand over the key. You just inform Hadoop that hey, here is my key and here is my value. So you are going to give NYC 20. Okay, NYC 20, NYC 20, and and so on. You're going to say BLR 23, and then you're going to say Seattle 25, and say Seattle, okay, Chicago 21. Okay, now once you have done this, Hadoop will group it. Hadoop will group it. Okay. Also noted that there could be a scenario that it is not ordered data. It could be in this format. Okay, all right. So here it could be like NYC and then 26. So this data needs to be first sorted and grouped. Hadoop will do it. You don't have to do it. All you have to do is write how to translate one record into key value, and that's it. And Hadoop will generate NYC 20, 20, 21, 26. Okay, BLR 23, and Seattle and Chicago, there are no repeated ones, so it'll look like this. Now, all right, now, now the next thing would happen is that you will write reduce code. And how would your reduce code look like? Reduce code will be very simple. Okay, key and values, and reduce code basically returns max of values. That's it. And magically you will, against every record, your reduce code is going to get executed, and there we are. All right, okay. So question is, what if we had to compute average? What if we had to basically sum and compute what is the maximum deviant data? All of that logic would go here. This is your piece of code, you wrote it, and this mapper as well is your piece of code, howsoever you want it. Only thing is, whatever key value you specify, Hadoop will basically execute your function and then gather all the key values, sort the data, and then group the data and hand it over one key at a time to your reduce function, and your reduce function will basically convert all the values for each key into singular. All right. All right. So yes, this Hadoop MapReduce is the job is basically, if you think about it, it's nothing but a huge group by function. It's a group by function. The way you do group by in SQL, Hadoop MapReduce is nothing but, first it runs your programs across, first it runs your mapper logic across the whole cluster, and whatever is the result, it gathers it, groups it, and then for every group is going to call your reduce function. And that's the magic. So you can always think of Hadoop as a giant grouping machine. Okay, Hadoop MapReduce, not Hadoop, Hadoop MapReduce engine is nothing but a giant grouping clause. All right, is everybody with me? Okay, so Hank, I would love to see your questions. I would love to answer those questions because those questions are very important, which are like 70% is still in the doubt, right? Question from Swan is age function of combiners are same as reducers? Yes, those are kind of reducers run on the same node. There is some another idea as we go, if we go into MapReduce in detail. If we go into MapReduce in detail, there is another idea called combiner, whereby the reduction happens on every node. All right. So I would actually like to, jump a little ahead. Yeah. So this diagram you see, okay, if we have to find the frequencies of the words, we could convert word into a column and one as numerical one into another one. Key will be word and value could be anything. So in case of SQL, we will write select star, select word, comma, count star from a table group by word. While in case of MapReduce, we print key as the word and so on, and this way. In our case, what we have just done, okay, so it's very similar to this, right? Select city, comma, max of temperature from a table group by city, right? That's what we will do. In our map, we basically wrote this piece of code. I'm trying to basically try to, I like Python's, clean logic because it makes my slides a little beautiful as compared to Java. I'm sorry if you are Java fan. All right. Okay, so I'm breaking the line by comma and then printing the city, comma, this. And then here I'm just saying max. Max is, let's assume for time being, there's a function called max, and this is what I'm doing, right? City, and these are temperatures. All right, bye bye. Then we will see you tomorrow. And let's not overflow because some other people, most of you would be having other commitments. No, Mapper does not sort data along with grouping. Yes, that's right. Software guys do for MapReduce to produce key values. Correct. So that's right. So when you write the code, you generally write in this form. All right. Great. See you tomorrow at the same time. I look forward to more questions. Think about the MapReduce little more. There would be some more assignments, and I would love all of you to go through those tomorrow. Thank you, Harishan. I'm happy that you find it very useful. All right. Okay. Because this is very important. So, Swan, we are going to do more practicals when it comes to Spark or the Hive than the pure MapReduce, but we'll give you some assignments. All right. Thank you, Azan. I'm happy that you're finding the class great. Bye bye. Good night. All right.